behind it catches the pieces. That plastic absorbs and spreads out the impact energy. Instead of one tiny spot taking all the force, the plastic disperses it across a wider area. By the time the force hits the next glass layer, it's much weaker. Layer after layer slows and stops the object. It's a team effort. Glass layers are hard. They flatten the bullet. Plastic layers are soft. They absorb the shock. That's why we use bulletproof glass in many places. Banks, government buildings, embassies, cars of important people, military vehicles, jewelry stores, some schools, anywhere with risk from firearms or explosions. It gives a clear line of sight with serious protection. But making this glass sandwich is complicated. So creating the perfect recipe is a huge scientific puzzle. Okay, so making this glass sandwich is tricky. How do you figure out the perfect recipe? Do you just keep making different sandwiches and shooting at them until one works? Well, that used to be a big part of the process, and honestly, it took a lot of time and money. But now scientists have a new assistant in the lab, and it's super smart, super fast, and never needs a coffee break. It's artificial intelligence, or AI. Think of AI as a brilliant scientist that can think and learn, but at the speed of a supercomputer. Scientists can feed the AI tons of information. Different types of glass, different kinds of plastics like polycarbonate, how these materials behave under stress, data from thousands of real-world tests. What happens when different types of bullets hit the glass, different speeds, different angles. The AI takes all this information and starts to see patterns that humans might miss. It's like giving someone all the cookbooks in the world and asking them to invent a brand new perfect dish. The AI can process it all in seconds. Using this knowledge, the AI can run thousands of virtual experiments. Instead of making a real piece of glass and shooting it, the AI creates a digital version of the glass on a computer. It can then simulate what would happen if a bullet hit it, change the thickness of the glass, try a new type of plastic, rearrange the layers, and then run the test again, all in a matter of minutes. This is a huge deal. Even with a super smart AI designing the glass, you can't just take its word for it. You have to prove it works in the real world. Once the AI suggests the best design, scientists build a real prototype. Then they take it to a ballistic range. They subject the glass to hardcore tests to meet safety standards. They don't just shoot it once, they fire multiple times with different ammunition. Handguns, high-powered rifles. Tests are incredibly precise. They measure the speed of the bullet. They measure the angle of impact. They record exactly what happens to the glass. Does it stop the bullet? Does it crack? They check for spalling. Spalling is small fragments from the back layer breaking off. Those fragments can be as dangerous as the bullet. A successful test stops the bullet, no spalling. AI makes the future of protective materials look incredible. Imagine glass that's bulletproof and super lightweight. Today, bulletproof glass is heavy and limiting. AI helps design materials with the same protection at a fraction of the weight. That enables lighter armored vehicles, more comfortable body armor for soldiers and police. AI could also create smart protective materials. Glass that changes transparency on command. Glass that repairs itself after damage. A window that slowly heals its cracks after being hit. Body armor that senses impact and stiffens instantly at that spot. Sounds sci-fi, but AI is accelerating material science. The path from a fragile phone screen to self-healing armor starts with one smart idea, and an even smarter